As you go east to west, latitude, you run straight down lines of latitude. Determine longitude, however, that's much harder, and you need to be able to keep precise time.
Welcome to Sea Class. My name is Crystal Rose. I'm the Curator of Collections here at Mystic Seaport Museum, and today we're going to be talking about navigation and navigation instruments at sea. So I'm here today with Mike Dyer, who is our Curator of Maritime History. And Mike, we have all kinds of fun stuff that we're looking at here today. Big general question for you. Going out on a whaling voyage, going out to the whaling grounds, what kinds of materials are you going to be taking with you in order to navigate?
Well, for one thing, they need sea charts. So, in your average general outfitting book, these little outfitting books that every master had to go through and tick off what they're taking with them, there'd be a complete set of sea charts. So, for instance, this is a really great one.
Super.
This is an American, published by Ian G.W. Blunt, a chart of the North Atlantic. This particular sea chart was used on board many voyages of the bark Sunbeam of New Bedford, which was, the agents were John and William R. Wing, the same agents of the Charles W. Morgan.
Yep.
Well, this is a Sunbeam voyage, but
we
so
have
you
lots
need
of
the sea chart.
photographs from Sunbeam too.
Oh, yeah, tons
Yeah,
of photographs.
Yeah.
Clifford Ashley sailed on the Sunbeam.
Yeah.
So I mean, you got the sea chart, but then, once you have your sea chart, then of course you have to actually navigate. So this is a particularly good sea chart, as we were discussing. This is a Blunt chart, but once you're on shipboard and you're actually going to navigate out into the open ocean, you need a number of instruments. And later on, when we go across the street to the planetarium, we're actually going to see some of those actual navigating instruments, octants and sextants, and these sort of sophisticated philosophical instruments, mathematical instruments, where a navigator can take the height of a celestial body and through a whole series of computations, put a spot on a sea chart. So, a book like this one, for instance, this is the great classic, and this is an American book. This is the New American Practical Navigator, 1852 edition. I think it's the 23rd edition or something like that. This one's great. It's bound in sailcloth. This thing was carried on shipboard and
Definitely used. Yep.
Yeah, it's great. It's a fantastic one. Navigation is really, really complicated, and I don't know how to navigate, but I know the bits and pieces. So, for instance, to determine latitude is a relatively straightforward observation of the North Star. That's what this other beautiful philosophical instrument is. This is a chronometer, exactly so, Crystal. It's a chronometer. This one's made by Thomas Porthouse, maker to the Admiralty. Right, so this guy Porthouse was making these instruments from the 1820s right up till when he passed away in 1860 in London, and this one has provenance connecting it directly to the Charles W. Morgan. So this instrument was carried on board the Charles W. Morgan. So you've got your point, right? You've got your point on the chart. Okay. You've got a compass. It can give you the direction you're sailing, and then at the end of the day's run, you make a pencil mark. And as you alter your course, that's when you would take an instrument like the parallel rules, and you line it up here with this compass rose, so that you know exactly what direction you're going, and then you take your dividers, and you'd make your day's run, and you take your pencil, and you mark on the chart.
Right, and this one is pretty marked up, right? This is Sunbeam is all over the place.
Look at all the whales on here.
Yeah, you see the little whale tails, yep.
That's right, and this is 1903, so Clifford Ashley was actually on board.
Yeah, so wait, but Mike, how would you even know, how would you even plan where you were going to go? People
have been navigating these seas for hundreds of years, and it is a compilation of exact knowledge. Yep. So, for instance, in this logbook, this is a log of a whaling voyage, and you can see that there are whales drawn in here, right? And it's a logbook, so it's got a latitude and longitude.
Right.
This logbook would be given at the end of the voyage, you give it to the agent.
Yep.
The agent owns 6 vessels, and the agent's dad owned 10 vessels, and his brother-in-law owns 3. And they compile information. So you can go through these and look for either the stamps of the whales or the drawings of the whales. You make a compilation. You
So
say,
they're trying to figure out where the most profitable places.
Yeah. Where to go? What time of year? You got the date, right? So here it is. It's
Right,
August,
August.
1877.
Where are they?
3150.
Yeah.
So they're in latitude 31 and longitude 50. So let's see, where would that be on this chart? So here's latitude 50 and longitude, what was it?
31.
31.
31 and 50. 50, yeah.
31 north. So that's, they're right here.
Perfect. Right here where
They're
you are.
Right exactly there.
Yeah.
Exactly so. So that's the way it works.
Yeah.
You compile that information, write it all down in a little notebook, and so you're commanding my vessel. I'm John Avery Parker. I'm telling Captain Rose that you're going to, you're going to go out. I want you to cruise on the western grounds for, say, 3 months in the summertime.
Okay.
And you know all about the western grounds, right?
Yeah, the Azores.
Yeah, right off the Azores. Exactly so. So you're on a sperm whaling voyage. You're only going to be out for 2 years, and I want you to spend your first 3 months, August, September, and October, cruising on the western grounds.
Okay.
And so that's what you did. There they are. You cruised out there, and you cruised around.
Mike, on this particular chart, was this all the same voyage, or do you think this chart was used for multiple voyages?
Many voyages.
Yeah.
Multiple voyages. So it's
Are
all
they
a
dated?
compilation
Like, are each of
knowledge.
these little lines dated?
Yeah. Well, this one's 1903.
Yeah.
There's there's an 1890 voyage on here as well.
Yeah.
So this thing was used. There's 1902. So this was used on, some voyages lasted for years, obviously.
Yep, right.
But then there are other earlier voyages as well. So it's a tool. They're all tools.
Right.
All of this stuff is it's science.
Yeah.
Right?
Yeah.
And commerce.
Right. What about the sand glass here?
Well, as we were pulling this all together, that's a Scrimshaw sand glass, and it's just a really super cool thing.
Pretty
and,
nice. By Scrimshaw, you mean it's made of bone?
Yeah, it's made of bone.
Made of whalebone.
Made on shipboard.
Yeah.
It's probably left over from some other sand glass part, the glass part. They didn't make the glass part. That would have been used for dead reckoning. So, for instance,
What's dead reckoning?
Well, dead reckoning is when you're not taking not using a chronometer to determine your longitude. Instead, what you're doing is heaving a log and line overboard. So you have a rope with knots on it.
Yep.
And it's on a spinning spindle. And attached to one end is a piece of wood called a log. You just throw that overboard.
Yep.
Right,
Okay.
exactly so. And then you hold it.
Yeah.
And it goes, and however many knots run out in the time that it takes you to,
And then you flip.
right? So,
How long have you been talking about this? Yes.
right. So, and that'll tell you the speed. So
Right.
once you have the speed of your vessel, then you can take, a latitude,
Sure.
right, and make a determination about how far you probably
You've
went
gone.
in the last
Yeah.
24
Okay.
hours, if you were going that speed. Right? So that's dead reckoning. And
Yeah.
when we go across the street, Brian's going to tell us all
Yeah,
about dead
yeah.
reckoning.
What about, so you mentioned using all kinds of fancy navigation instruments. You mentioned being able to see celestial bodies. What happens if you can't see the celestial bodies? What happens if you can't?
Then there's
if
another
it's bad weather, or
right.
cloudy, or
Yep. Then there are other sets of instruments that you can use, like a false horizon, for instance, which is a pyramid-shaped piece of glass, in order to take a sight, and also the log and line. It's very important. The whole means of dead reckoning. So, again, I don't know how to navigate, and I'm not going to pretend that I do. So my description of the artificial horizon may not have been exact, but Brian can tell us all
Awesome.
about that and how they were used. But what's really interesting about these materials is that these materials were available in seaports all around the world. So there were
Right.
navigating, what they called navigation warehouses,
Sure.
or nautical stationers, right? Or just navigating instrument makers in seaports everywhere.
I'm glad you brought that up, because actually if you're a visitor and you come to the museum, you can go into the village and you can actually go into our nautical instrument shop.
Yeah.
And you can talk with an interpreter there who can tell you about some of these instruments. So.
And that's what you get. You
Yeah.
can get blank logbooks, you get sea charts, new and used. You can get navigating instruments, new and used. You get pencils, you get paper, you get dividers, you get parallel rules, you get copies of all these books. Here's a set of tables that's also published by Bowditch, which goes along with the Practical Navigator, which is a book of instruction. And so, these are all tools that are used together.
Well, Mike, who
figure
on
out
board?
who you were and where you were going.
Okay, so 2 more questions. Where would all of this have been done?
Oh, right.
And who would have been doing it?
Yeah, that's the master. So
Yeah.
the master of the vessel would have had all of these materials in the cabin, like aft, below decks in the cabin, laid out on his work table, and it was his job to make a determination about set the course for the vessel. The mate actually kept, the mate could navigate. The mate could take sights, so she could take, lunar observations.
Sure.
It was the master's job to do that and to keep track of that on a slate. We just recently acquired one
purchased
of those
one. Yeah.
cool slates.
Yeah.
So you just
The
write
James
it down.
Allen.
That's
Yeah.
right. Yeah, James Allen. That's right.
Yeah.
So you write that down in chalk, and
Right.
then at the end of the day, it's the mate's job is to keep
Yeah.
this logbook
Right.
for legal reasons. It's to keep,
Exactly.
so that there's a disinterested third party is
Right.
keeping the log of the vessel. So the master, will take the sights, write down the information, and then the first mate will enter it into the logbook.
Sure. We actually have another example of Lottie Church, who was the captain's wife,
Oh, yeah.
who actually did some of the navigating, and we have her notes from that as well. So.
Yeah. There's also that really interesting
I know that's not as
photograph.
common,
No,
but-
no. Well, there's that interesting photograph of Horace and Marion Smith in the cabin with the
Oh,
chart laid out,
yeah,
and she's, he's laboring over the chart, and
Right.
she's,
Marion Smith, our photographer
that's
and
right,
whaling
that's
wife.
Right, that's right.
Yeah.
So there were highly skilled women navigators who were involved in the whale fishery for sure.
Yeah. Excellent.
Yeah.
Well, Mike, this is awesome. It's been delightful to learn about all of these different instruments and these different books. So I think the next step is probably going over to the planetarium to learn a little bit more about how these would have been used. Hi, we're here with Brian Kohler, who's the Associate Director of the Tourgy Planetarium here at Mystic Seaport Museum. And Mike is joining me again. After our conversation yesterday, we had more questions about how things work exactly, some of the navigation objects that we were talking about yesterday.
The objects and the processes.
Yeah. So this is the guy who knows all the info. So Brian, I can see that you're holding a sextant, which is one of the things we didn't look at yesterday, but we were discussing. I understand this is a way that you can navigate at sea. Can you tell us a little bit about this instrument and what it does? How do you use it?
Absolutely. This sextant, when you look at this instrument, this is probably one of those iconic things you picture when you hear the word navigation. We see this image, this shape, and what this tool ultimately does is it measures angles. Specifically, it measures the position of objects in the sky. You can use it to measure the altitude of the sun, the moon, a planet, a star, pretty much anything that is up there in the sky can be measured. What those angles ultimately do is they help tell you where you are. The angle of the North Star, for example, can give you your latitude, your north-south position over the globe. Here in Mystic, Connecticut, that North Star is always 41 degrees above the horizon, and our latitude is 41 north.
Cool. So another question that we had yesterday is, what if it is cloudy or there's bad weather and you're not able to see some of the, you're not able to see the sun or you're not able to see the horizon. How do you navigate in that instance?
Right, so what happens then is this tool can't work anymore. So there's another method of navigating that's been done throughout history that is known as deduced reckoning. It's sometimes shortened to dead reckoning, sometimes it's even shortened even more to DR. And the idea behind this is, at some point in the recent past, you knew where you were. Maybe it was 10 minutes ago, maybe it was an hour ago, maybe it was yesterday. But whatever that known position was, that is your fix. And if you're gonna use DR, you're gonna take that fix and you're gonna say to yourself, what direction was I headed? How fast was I going? And how much time has transpired? You put those three things together and you project your fix, and now you say, this is where we think we are. I'm sure by the way I'm describing it, you can figure out that this is an inexact science. Right. There are so many variables that can throw that DR position off.
So this is kind of like yesterday when you were describing the chip using
the chip and log and
yeah.
the sand glass.
Yes, because that's an important piece of it. So the chip log, the long spool, this all ties into how you measure speed of a sailing vessel. You would take that chip log, that long spool of line, you would throw the weight off the back of the ship and you'd allow the line to run. But in order for this calculation to work, you need a very precise amount of time, and that's where that sand glass comes in. So you let the line run. When the sand glass is up, you grab that line. As you're hauling it back into the boat, there are knots tied periodically across that line. As you're hauling the line back into the boat, you count the number of knots that have gone into the water. That gives you your speed in nautical miles per hour, which many of us here in the maritime world know. We measure nautical speed in what are known as knots.
Knots, right. And so we had the dividers, which would have given us a fixed point, and then you calculate the speed of the vessel and the direction from the compass.
Yes.
And then you take those dividers and you make your next dot and hope for better weather the next day.
Right, and then as soon as the sky clears, you go back to navigating with the sun and stars because you need to figure out if your DR is anywhere near accurate.
So what can happen if you're off a little bit?
Then you make a course correction. So when you go through a logbook, you'll see that today we're using DR. This is our estimated position. The next day the sky is clear. Oh, turns out we're here now. And so when you're plotting your course on the chart, you end up with these sort of dotted lines. That is your DR position. And then when it's corrected, now we're drawing straight lines and saying this is our actual position and our actual course.
A lot of times in logbooks you'll see it'll actually say by chronometer or CHROM. So it'll
yes.
and then other times you'll see, and this was sort of common in the earlier part of the 19th century. They'll see little illustrations of the moon.
Yes.
To indicate that the site was taken by lunars.
Yes, that's right. And I'm glad you brought up the chronometer because when we were talking about the sextant, we were only really addressing half the puzzle, right? We were talking about latitude. You need to know where you are east and west. So you've actually identified the two methods that were quite common during the time the Morgan was sailing. You had longitude by chronometer, which was essentially figuring out a time distance from 2 points on the globe, or you had what you referred to, which was the lunar distance method. So you have a mechanical solution using the chronometer, a mathematical solution using lunars. And for a period of time, sailors are really using both methods or one that they prefer, depending on if the navigator is more mechanically skilled or more mathematically skilled. But it does appear that the Morgan used both methods over the course of her voyages in the late 1800s.
You know, I liked earlier this morning when we were chatting, you were saying that some of your you give your students exercises to do, and sometimes they come up with different numbers, which is fine in the open ocean, but in a closed body of water, what happens if those numbers aren't exactly right?
Well, that's why the key to these instruments is precision. So yes, when we practice this in a very comfortable classroom setting, we have a sample item to measure on the wall, and somebody gets 32 degrees, and somebody gets 33 degrees. Okay, well, we're practicing, that's okay. But the difference of 1 degree of latitude, we're talking 100 miles. And so that's a big difference, right? So this instrument, this sextant we have here, not only measures individual degrees, but it actually allows you to get into the fractions of degrees. So now we're not talking about measuring 32 degrees or 33 degrees. It's a measurement of 32 degrees and a certain number of hours and a certain number of minutes. So we're trying to make that measurement as precise as possible.
Do people still use these today?
They do, yes.
There's GPS now. Why would you need this?
That is true, but technology is not always the most reliable thing in the world. So here at the planetarium, we have had the opportunity to work with cadets from the United States Coast Guard over in New London. We work with officers in training from the U.S. Navy base out in Newport, Rhode Island. Both of those organizations still use these instruments. And yes, they have the computers to do all of the work to back them up.
Gotta have the backup.
Right, and they're keeping this skill alive and then checking their human measurements with the computers to say, we still know how to do this.
Yeah, excellent. Very nice. Well, thanks so much. I don't think I have any other questions for Brian, do you?
I don't think so. It's just, we're here at Mystic Seaport, of course, at Mystic Seaport Museum, and we've got a lot of navigating instruments of all various kinds. There's backstaffs and crossstaffs and octants and quadrants and sextants and
yes. So this is sort of the end of the angle measuring evolution. Those objects you've listed, some of them came about in the 1400s, 1500s. When we first understood the link between angles and latitude, some of the very early measuring tools, their accuracy left a little bit to be desired. Some of them required that you look directly at the sun. So there was a safety issue at play. Now this instrument really being the end of the evolution, there are filters on this instrument that we can use to filter out the sun's light. So it's like looking safely at these objects. So it's been interesting to see how those tools have evolved. We've actually got a few of them on display right here in the planetarium.
It's the progression of science.
Exactly, yes. You see the improvement in safety, the improvement in accuracy, and the innovation that has led us to a tool that came about in the 1700s, but as Crystal noted, still gets used today.
Sure, yeah.
Thanks, Brian. Thanks
Absolutely,
so much.
yes, thank you.
And thank you for joining us for this episode, Navigation and Nautical Instruments at Sea.